So, today is pretty much reserved for your questions. I don't usually, you know, I'll kind of go wherever the questions lead me. Are there any questions about, there's a test Friday, right? Yep.
The only thing I gotta ask is, when you say use real or complex solutions,
Use real or complex solutions. Let's see here. Let's look at, that's in the quiz, right?
yes, sir.
Number 7. Yes, I say find real or complex solutions of these, quadratic equations. So, why? You get it? Thank you. I'll take it. Thank you. I don't know. Yeah, last time I did it, I got up on a chair, but so find real or complex solutions. So like when the quadratic has a discriminant, which is negative, right? Corresponding to the case when we complete the square and we get the squared plus a number squared, that case is when there's no solution in the real sense, right? But we can always find a solution in the complex sense. Like there's fundamental theorem of algebra says if you have an nth order polynomial equation, there will always be n solutions if you allow repeats and complex solutions. So let me go back to the solution here. So like the first one, right, this one, you notice that we got, like, we complete the square, and we get x plus 4 squared minus 10, right? We good? So I said, so this is the other issue that persists throughout both sections of pre-calculus. And the issue is this. There is a difference between an expression versus an equation. Right? And so there's a wholesale confusion on this point. All right, so like expression. This is the answer to a factor completely problem. Or a simplify. Simplify this expression. Expressions even in the instructions to that one, right? So that one's kind of hard to miss. But in contrast, an equation, well, that's something where you're like solve, some expression equal to some other expression, right? And this is usually in x. This is also in x. And your solution is going to be something like x equals to blank, comma blank, whatever, right? So when we solve an equation, we're expecting like a list of numbers or the statement that there is no solution at all, right? That's very different than factor completely or complete the square or simplify the expression. There, the answer is not a number. It is an expression. It is a sentence using a variable and number and arithmetic, right? That's very different than solve this polynomial equation. But a lot of you still have in your head these two things like soldered together. Because when I ask factor completely and I ask solve, people give me the answer to both for both questions. So they're not distinguishing between the problem of solving f of x equals to 0 versus the problem of factoring f of x completely. These are related, but they're different, right? Like, for example, I have f of x equal x squared plus 5x plus 6, right? Factor completely. No need to complete the square here. We can use simpler things, right? Just garden variety factoring. So, factored completely. An expression, right? Solve versus solve x squared plus 5x plus 6 equal to 0, right? That is a different problem. And the answer to this is also related to the thing we just did, right? But it's not the same. So the solution here is given by the principle that the product of two things can be 0 only if one or the other is 0, which tells us that x is equal to -2 or x is equal to -3, right? Those are my solutions. Now, there are other kinds of problems where the solution aren't just lists of numbers, right? They're like whole sets of numbers. That happens with inequalities. So an inequality problem also has an answer which is not an expression, right? It's a set of numbers, but there it could be infinite, right? We use the like interval notation and stuff to kind of capture that. Does that?
A little bit alike. So what I was asking, because I didn't answer your question, so like I got to the point where you complete the square, but I didn't, put the I and stuff like that. Like that's kind of what.
Right, so that's what it says, and find all real or complex solutions of f of x. You're asking how to do it. You're not, okay. Okay, so how do we do it? How do we solve?
Like I wanted to know what it is, and now I want to know how to do it.
Sure. So I just talked about what it is, I guess, at the moment. Here's how to do it. So when we have ax squared plus bx plus c equals to 0, right? There are basically three things that can happen when you complete the square. The one thing that can happen is you have a times x minus, let's say, alpha squared minus beta squared. That's one pattern. The other pattern you can have, the other pattern that happens is when you just get the constant times just a square. The third thing that can happen is this. We can always complete the square, and it will work out to one of these three cases, where alpha and beta are numbers that depend on the given problem. I can write formulas for them if you want. Like alpha is equal to what? Oh, I guess it's annoying because there's that A there. No, you're not supposed to know it. I'm saying you can. What? What are they equal to? Different things for different problems. I'm saying that those are the patterns that happen. So like when you complete the square, if you end up with a minus versus you end up with nothing versus you end up with plus. So the top case is when we have distinct real solutions. The middle case is when we have a single real solution. And the bottom case is when we have complex solutions. Those correspond to the discriminant being positive, being 0, or being negative, like we talked about before. Yeah? So when you set this equal to 0, you end up with the problem x minus alpha squared equal to beta squared, right? This one, you end up with the problem x minus alpha squared equal to 0. This one, you've got x minus alpha squared equal to minus beta squared. So like the top two, you just take the square root of both sides, and you get x is like alpha plus or minus beta, right? So I'm running out of board space, unfortunately. But this says x is equal to alpha plus or minus beta. This says x equals to alpha. And this last one, the most interesting, this says that x minus alpha, and I can write the work down here, plus or minus the square root of minus beta squared, right? But that we can write as I times plus or minus the square root of beta squared, which we can write as I times, well, plus or minus I beta. In other words, x is equal to alpha plus or minus I beta.
Can you put numbers in it?
Yes.
Instead of?
Yeah. I was getting there. So f of x, say, equals to x squared plus, say, 16x plus 66. Let's complete the square and find the real or complex solutions. So, so we do x plus 8 squared. I did what? I added. Oh, yeah, you keep your quizzes in here. Yeah. I know some people keep, like some other instructors like collect quizzes back. That's fine. But I keep making up new quizzes, so it doesn't matter. You can have them back. The fraternities and sororities collect all my tests. It won't matter. It's not going to make a bit of difference. All they're going to end up doing is studying math. Victory for me. See, once you got about 10 different tests out there, it doesn't matter if you repeat one, because if they're smart enough to find that one test out of the 10, you just tricked them into studying 10 math tests. So, sorry. Anyway, x plus 8 squared, so that I have to subtract 64, right? So this completes the square to plus 2. Right? Do we agree? Sometimes I write down a middle step there. I haven't lost you, have I? Okay. So we've completed the square. Answered that part of the question. Now, so f of x equals to 0 is the same as what? It's the same as x plus 8 squared plus 2 equal to 0, right? Which we can rewrite as x plus 8 squared equal to minus 2. In this problem, the alpha is equal to minus 8, by the way. And beta, I usually take to be positive square root of 2. If you want to think about it in terms of alpha and beta. So then what do? We take the square root of both sides. Remember, we have to account for plus or minus. So this gives me x plus 8 equals to plus or minus the square root of minus 2, which then the square root of minus 2 is I times the square root of 2, right? Because that's plus or minus like the square root of minus 1 times the square root of 2, the way we could think about it. But square root of minus 1 is I. This is like plus or minus I root 2. So we get x is equal to minus 8 plus or minus I square root of 2. And there you go. Those are the complex solutions to this one. All I'm really doing here with the alpha and beta is like breaking down the quadratic formula into pieces. I just haven't actually given you formulas for alpha and beta. It's actually easier for a specific numerical problem to complete the square and go through this as opposed to blindly using the quadratic formula. I used the quadratic formula for many years, only until I finally came to the realization that completing the square is actually faster. And I've taught students using the quadratic formula, but I stopped. And the reason I stopped is, while I understand how to use the quadratic formula, they don't. And what you guys will do is you will half use it. And like in the calculator, it gets twisted, and it's really hard as an instructor to give partial credit for like misuse of the quadratic formula. So if you are comfortable and you have a mastery of the quadratic formula and you want to use that to solve some of these problems, that's okay. But I do ask you to complete the square though. So I mean, I have to, it kind of depends on the rails I put on the problem. If I haven't put rails in the problem, you're free to use the quadratic formula, but use it carefully, right? Of course, if you know how to use the, your calculators have like a root finder too, that can help you check your answers, right? Do you guys know this? I mean, I don't know for your calculator, there's like, you know, dozens of different kinds of calculators people are using, right? But the one I have, this guy, in here, somewhere in this thing, and I use the root finder. I think it's probably bad practice to use the root finder in a class like this because typically your instructor is probably going to give you solutions that usually have answers with numbers, like whole numbers, because we don't take joy in grading answers that have fractions because it's pain. So it's just us being lazy, personally. But if I'm in a physics class, I cannot avoid physically reasonable problems from having really difficult arithmetic, right? So it's not unusual for like a quadratic equation to have solutions that are like 3 times 10 to the minus 7th and 4.2 times 10 to the minus 5th or something, you know? And for that kind of problem, I think using the like automatic polynomial solver in a calculator, that's the way to go, right? So, but that's not here, is my point. But on this one, it's like, I think at the top you can hit, I get like solve equals is a button. So I go solve equals, how's it go? Oh, who cares anyway. Well, I guess it's been so long since I've used it, I've forgotten how. Because honestly, if I'm near a computer, I'm just going to stick it into Wolfram Alpha because it's just, you know, easier to see the numerics there. I shut up. Does that help? Should I do another one?
So when you got x plus a squared equals -2,
Mm-hmm.
like where did the square root of -2 come from?
I took the square root of both sides, so like. Now, some professors would even object to like, there's some people who think that this isn't rigorous. Those people insist on factoring. And you could like factor. You could take this and you could replace it with x plus 8 squared minus 2i quantity squared, because I squared is -1. So you can change the +1 into a minus an I squared. And so doing, you have the difference of squares, and then you can just straight use our usual difference of squares, you know, formula. You factored it completely, and then you can read off the roots as -8 plus 2i to -8 minus 2i, just like we found with taking the square root of both sides and doing plus or minus. You know, that's also a legitimate way to solve this. I think actually using the quadratic formula would also be a legitimate way to solve this, because I didn't say use completing the square to solve it. I was trying to lead you there because it's easy, but I can't force you to do that. I mean, when I say solve it, I can't stop you from solving it some other way, you know? I mean, I could, but I have to write a paragraph of stuff to really like pin you down. And by the time I wrote that paragraph, I would either confused you or made the problem trivial, so it's stupid. So I won't do that. In fact, I try to be pretty close to the wording of my, I try to stick to the wording on my quiz. Like, I might have different formulas and stuff, but as far as the actual wording of problems goes, I try to stick with what I said on the quiz already, just to minimize confusion about like instructions, because I don't want that to be the issue on the test. I do always try to ask like one new question that's challenging on a test, typically speaking, but it's usually bonus. I'll do one more and we'll go on. So if we had something like now I have left the world of the quadratic, right? So how would you factor this completely? This is a quartic, right? So we tilt your head and squint, and you can say, that's x squared plus 10 times x squared plus 1, right? By the way, I talk sometimes about completing the square being stupid when it's like a factor squared, but this is actually another example where completing the square is kind of dumb. If there's no linear term, how does completing the square go? Like if there's no bx term in your quadratic, what's completing the square look like? Looks like it's already done for us, is what it looks like, right? I mean, these are, square is already completed. There's no linear term, right? And so what can you tell me about, I mean, that's factored completely, right, over the reals. What would it look like if we wanted to factor it completely over the complexes? Like, can we factor this using complex numbers? We can, right? We can always factor over the complex numbers. Did you have homework on this? I don't think I gave you homework on this. Did I? I did. Oh, okay, good. Then it could be on the test, right? Thank you. Phew, that was close. I almost struck it from the record. I don't want to do that. But this was not on the quiz, was it? No. I mean, it was on the... the only thing on the quiz was complex, I think, was the quadratic question. Was it?
Is that I or is it just one?
This?
Yes.
That's 1.
So wouldn't it just be 1?
Well, this we could rewrite as x squared minus 10i squared times x squared minus I squared. Because I minus I squared is 1. So we're kind of getting into the weeds here. This is what I would consider like the second tier of understanding for the test, right? Like there's lots of people in here who could make an A on the test and not completely understand what I'm doing at the moment. Let me get us back on the rails here for a second. So suppose I just want to factor over the reals. Am I done? Where am I done? Where am I done if I just want to factor completely over the reals? Game over right here, right? I cannot go further than that because to go further I need complex numbers, right? And what if I wanted to solve f of x equal to 0 over the reals? What would you say? As what? It has no real solutions, right? In fact, all of the solutions are genuinely complex, right? Like plus or minus I root 10 or plus or minus I. These are the solutions. All the solutions are imaginary. So there's no real solutions, in fact. We'll talk about later in this course that corresponds to the fact that if you wrote y equals to that quartic and you looked at its graph, it opens up and never crosses the x-axis, right? So, all right, we've done other things besides this, right? So I think another common source of confusion, or maybe you avoided it. So part B So when we have an inequality, absolute value inequality is greater than something, how does that work? There are two cases, right? There's two disjoint cases. The one is that the quantity can be less than minus whatever we have as the bound below, or the quantity can be greater than the bound below, greater than the 5. So we have to solve these two guys separately. They work out for this problem, 2x less than minus 4, 2x greater than 6. Divide by 2, we get x less than minus 2 or x greater than 3. You cannot have one x with both of these, right? So the solution is two different disjoint intervals on the number line, and we can write the solution in terms of a union of those two rays, two intervals. Now, a lot of you instead chose part A because it's like way easier, right? Except that it has the scary thing, fractions. Yeah, I was curious, like how many people would bail on part A just because it had fractions. I was curious. But A is much easier. It's just a plain linear inequality. Actually, I was thinking of writing a test for the class below this, that are intermediate algebra, and like have the same question repeated, once with fractions, once without fractions, and just like keep doing this. Same question, but with or without fractions, and then like study how it affects the outcome. Like how much is mental loading of fractions hurting the students in 101, you know? Be interesting to study. But I probably won't get around to it. So this is the other thing I would encourage you, if you have not figured out what I'm doing for these problems. I mean, I've spent a lot of class time on it. I've spent more class time on this than the test will be on this, right? Because I know it's something you guys don't know yet, and I want to kind of drill it in because this is something we use in calculus a lot. So this one here, I have x plus 4 squared, x plus 2 cubed, x squared, x minus 3 to the 5th. X minus 3 to the 5th, yeah. So you can read from this, minus 4, minus 2, 0, and 3 are my algebraic critical numbers. Oh, thanks to myself for having it already factored. There we go. And then, so that's even. What do I mean even? Is 4, minus 4 is even? Well, that makes sense. 4 is even, right? But minus 2 is odd. What? What do I mean by that? What am I actually? I'm not referring to these numbers, right? I'm referring to the power which appears in the corresponding factor, right? So like minus 4 is this x plus 4, it's got a square, right? X plus 2 has got a cube. X has got a square. X minus 3 has got a 5th. So the even ones basically never change sign. We can essentially ignore them. And we just have to focus on the odd ones flipping signs, right? So here's the number line with the algebraic critical numbers. It is important to put down the ones that correspond to 0 because you might need to exclude them or include them depending on whether or not you're looking at something in the denominator or something in the numerator, right? Division by 0, bad. Multiplication by 0, you know, not bad. Anyway, so there you go. I plugged in some point somewhere in here. I forget which one it was. Doesn't really matter. We could plug in like 4. If you put in 4 here, you've got plus, 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 plus. You got positive to start with out here. And then since this 3 comes with an odd factor, I flip signs. Since 0 has an even, since it's x squared, I keep the sign. Minus 2 again, x plus 2 is cubed, so it flips the sign. And then minus 4 doesn't flip the sign because it's got the square there. And then I look and say, okay, I'm looking for positive, so I look for my pluses. And I put it together, make sure I don't include something that's got division by 0. I got to worry about 0 and 3. And so I have to make sure that I've got this open interval here to exclude 3, right? There's a few of you who are being careless about open versus included, included versus excluded, but I'm sure that'll be fixed by the test. It's not a big thing to fix, right? It's easy enough to miss. other questions? I think most people got problem 11. And that's really good. It seems like some people are better at completing the square when there's 2 variables versus when there's 1. I don't know. It's kind of a funny thing. But so I think you guys can do that question. So I don't need to test. I don't need to put that on the test, right? Because you guys got it right in the quiz. I mean, right? If everybody got the question right on the quiz, I shouldn't put that on the test. We already have established that you can do that one. It's not interesting to ask it again. Does this make sense? You're like, this kind of humor is inappropriate before a test. You should save it for afterwards. And only if we do well. Fine. Word of caution. I noticed a lot of you are thinking that you can just basically get one solution here. Not a lot, but maybe 30% of both sections. So beware, you got to account for the plus and the minus. There should be 2 solutions here. This one, very fortunate happening that we've got this x both places here and they canceled. And it just left us with a single solution. More often than not, these come out to like 2 solutions. And like one of them will be extraneous, one of them's not. It is also possible to have questions like this where you get no solutions at all. In fact, when I just start plugging stuff into Wolfram Alpha, like playing around, more often than not, when I just look at an equation involving roots, I get no solutions. It's pretty easy to come up with those. So, and I hope you guys have noticed that, the dreaded, how did you guys fare on this one? The other section had a lot of trouble with this one. Do not give up on this problem. This is a skill you need to master. Everybody can get this one right. Just got to be methodical and like take it step at a time. You know, work it twice. Double blind, right? Like work it, take a piece of paper out, work it again. See if you get the same answer. If you don't, work it a 3rd time. Then take the average of all 3 answers. No, do not take the average of all 3 answers. If you repeat answer twice, it's probably that one, right? I don't know. Check your work on this. This is definitely a blind spot for a lot of people. I saw a lot of wrong answers there. And I think you guys are by now sick of hearing about interval notation, so I'll not say any more about it. Do you guys like problem number 1? Yeah. That's a happy place, isn't it? All right, well, I will shut up and let you guys go. So you can hit the stop record if you don't mind. And again, I got to run and go print something, but I have a couple minutes to talk to you if you have a question. I know people often have questions afterwards. Did you get it? It's on the side.